Hey everybody, welcome back. By popular demand, I'm going to be going over some basics on how to program in Python. Um, Following from the previous video, I am going to be using Google Colab here. Feel free to follow along. I'm going to, at least hopefully I will remember, to link this notebook in the video description so you can learn along with me. Alright, so we're going to start at the very beginning of programming, which is variables. Now, what even is a variable? We can think of a variable as a container that holds a bit of data. Generally speaking, there are 5 general types of variables that you can find in any programming language. So the first one is an integer type. So this can hold, if you remember back from math, integers are whole numbers as well as their negatives. So we can have a variable named integer here, and we can call it 5, 10, -1, and all of those are fine, and it will be stored as an integer. Floating points include anything with a decimal. So if we wanted to have 5.3 or 3.83579, all that fun stuff. A character is any printable character, anything that can be essentially found on a keyboard. In Python, we assign characters with single quotes. So let's say we had a J. That would work. What about capital A? A %sign. There are some special characters as well. Usually you can get those with a /, or whatever that is, whatever slash that is, and then your special character code. So a /t is a tab, /n is a new line, just like hitting enter on the keyboard. Stuff like that. Now a string is essentially a big ol' collection of characters. In Python, we use double quotes for strings. We can put whatever we want. Hello there. And so this string would essentially have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can't count. This many characters, and then follow it up with a new line, which means the next thing to be printed will be at the next line. And finally, most languages have what's called a Boolean type. All this is a true or false, a 1 or a 0. And it's useful for control structures later on in programming. So let's just say false. There you go. And see, here in Colab, it's recognizing, oh, false is a keyword with the type bool for Boolean. So it's going to say, hey, do you want this? We can hit tab and say yes. So Python, let's talk about this first. Python is what is called a dynamically typed language, which means that when we assign a value, or we create a variable, I should say, when we create a variable, we do not need to tell it what type this variable will be. Right? So in some other languages, if we wanted to say that we had a variable for an integer, we would have to say int integer. Here in Python, it's going to say, oh, it's going to give us a red line, say, oh, this is wrong, you can't do that, because it is dynamically typed. It will see whatever you're trying to put into the container and then make it the appropriate type. This just makes it a lot easier for new people, as well as when you get later on and you have more abstract data types. That makes it a lot more interesting there, or a lot more useful, I should say. So here in Colab, if we want to run this, all we have to do is come over to the play button on the left, click run, and boom, there we go. So now the computer that, or the remote computer that we are running all this code on, has now stored these 5 variables with these values. Alright, so now we have some values in our variables, but that's not super useful if we can't access these values. Right, so the computer has remembered that we have a -1 in integer, but how do we access that value? Well, the easiest way to do that is with the print command in Python. So this will just print whatever you put inside these parentheses to the screen. So let's do that here with integer. And we see that integer currently stores -1. Let's also do that with our string variable. Hello there. And then see how this is slightly wider than it was previously. Let's do that again just to compare. -1, see, it's not quite as wide. That's because it is printing the text from hello there and then the new line right after. So that's useful for text formatting if you ever cared to do that. Print statements are also very versatile in Python. So we can go ahead and put any sort of string that we want into it. So let's say my string of text, period. And then, so let's print that, and it will print just the raw values here. We can also put our formatting into it. So let's say we got a /t, and then we want some, let's just show off the tab here. And you can see it pushes it over by 1 tab. So that's cool. Printing is very useful later on when you want to debug your code. You want to look at what's happening as the code runs. Print is a very, very valuable tool for doing that, as well as just for doing other outputs to the screen. So cool. Now we can print out some variables that we have. We can print out regular old text as well. That's cool. What about math? This is when we can start doing actual useful work with our programming. So let's go ahead and tell the computer we want a variable named a to store an integer 5, and then b to store an integer 3. Now, let's say we wanted to see the sum of that. So just like in regular math, you can say a plus b, and then if we print that out, we get 8. That's exactly what we expect. So that's pretty useful. We can also subtract. Sure, that's 2. We can multiply integers. 15. Nice. And we can divide. Well, now here we're going to get something interesting if we divide. So what is 5 divided by 3? That's what, 1 and 2/3? However, look what the computer is going to give us. Oh, 1 and 2/3. Well, there you go. It is automatically recognizing that, oh hey, we're going to have a remainder going on. We probably want to capture that value. So that's useful. What if, let's say, we wanted to store our sum, because we can do that. We can store a plus b into a third value c. And then, let's say we wanted to do something like this. We want to have a divided by b multiplied by c. So just like in algebra from high school, we're going to follow, or the computer will follow the order of operations by doing the quotient first and then multiplying. So there we go. We have our 1 and 2/3 multiplied by 8. We get 13 1/3. That seems about right. One useful and a little strange operation that we can do is called the modulo command. So modulo is done in most languages with the %. And let's just see what it gives us. 2. Okay. Hold up. Yes. Right. Modulo will give us 2. So what is going on here? Essentially what we have is the modulo command, or the modulo operation, I should say, is dividing a by b, and then it is grabbing the remainder. Right? So previously when we divided, we had a divided by b, we got 1 and then 2/3. So what modulo is doing is taking this 2 divided by 3 part here, and it's just giving us the remainder of 2. If you remember doing long division from school, it's the same exact remainder. So here you go. This is really useful in certain scenarios. So let's say that a is 8 and b is 2, and then we want a mod b, and we'll print that output. So this gives us 0. But what if a was 9? A mod 2, or a mod b, becomes 1. So essentially what we're doing here is we're checking to see if a is even by dividing it by 2 and then seeing if there is indeed a remainder. We are seeing if 2 evenly divides into the value of a, and if it does evenly divide, it will spit out a 0 and tell us, hey, this is even. Otherwise it will tell us, hey, it's odd. Also, it looks like my bad internet is now... Oh, we're back. Okay. See, so 7 mod 2 will print out a 1 because 7 is odd. So now we have some math going on. That's useful. But what if we have some users of our code and we want them to be able to give an input, but we don't want them to change or to be able to see the code behind the scenes. So how do we get that input? In Python, that is very simple. There's a command called input, where you provide it with a prompt statement, and then the prompt statement will be printed to the screen, and then it will await user input from the keyboard, and then that input, once the user hits the enter key, that will be stored into the variable. So let's go ahead and do this. So as you see here, the spinning wheel says, hey, we're currently running this line and we're waiting for input. So our prompt has been printed right here. So let's go ahead and say test. And then if we hit enter, it'll spit back out test, because that's what we told it to do. So that's really useful. Let's go ahead and put all of these together into one little thing. So let's go ahead and store x. Let's get x from the user. Number to test. And then we're going to also store y as 2. So we're going to grab input from the user, store it into x. Y is going to be 2. And then z can be y x mod y. And then here we're going to have a print statement that says x, comma, which means we want another thing for it to print. We're going to say x, comma, modulo, comma, y equals z. So actually, let's go ahead and say to test modulo. There we go. All right. So let's go ahead and run this. Oh. It worked earlier. All right, well, I figured this problem out. It's saying that we have a string and it's not callable. What does that mean? So let's turn this into a little bit of a lesson. Essentially, what I did wrong is I created a variable the same name as some command that I'm using. And then when I try and use the command again, it currently remembers the previous value of our input variable. So it's trying to use the variable input instead of the command input. So that's why you never name variables the same thing as standard commands. So now this works just fine. And then when we do this, I went ahead and reset the runtime over here. You can do that by clicking this in Colab. And now it should have forgotten the value of our previous input variable. So when we run this again, so now this is doing what we expect. So let's give it a number 9. So this is, again, one of the few times that data types actually kind of matter in Python. So what we're going to do is do what's called typecasting. We're going to input is grabbing the value from the keyboard as a string variable and storing it into x as a string. And then it's z is trying to do math with a string, which is why the error is pointing to this line. right? And it's saying we're trying to do some stuff with a string, right? So if we typecast it into an integer and then do math with it, we should be good to go. So now let's try 9. And there we go. We got exactly what we expected. 9 mod 2 equals 1. Let's run it again just to make sure. 7. 7 mod 2 is 1. Negative 2. Oh. Forgot to hit enter. Negative 2 mod 2 is 0. Perfect. So there you go. Let's go ahead and summarize what we've covered today. Programming uses these things called variables, which are exactly like the variables from your algebra classes. They're essentially a container that stores a value in the computer's memory. There are 5 major types, at least 5 major types that you need to care about. Those are integers, floating points, characters, strings, and Boolean values. These variables can be called in order to retrieve their value, and they can be printed to the screen with the print command alongside some special formatting and other strings of text. We can also do math with these variables in order to achieve relatively useful outputs. And then we can also get input from the user in order to affect how our code executes. And then we can put all these together to make simple scripts like these in Python. Well, thank you for watching. I hope you learned something through this, and I hope you enjoyed. I'll catch you in the next one. Bye-bye.